Hi guys, welcome back to my YouTube channel. Today we want to find the value of x, given that we have x raised to power x raised to x plus 1 equals 2. So guys, let's have it to be solution. So guys, we have x raised to power x plus 1 equals 2. Now from here, from this one, by considering this, when we have a raised to power m plus n, this equals when you have a raised to power m dot a raised to power n. So by applying this expression here, then we are going to have this to be x raised to power x, then dot x raised to power 1. Then we have everything to be equals 2. And likewise, from here, we have, when you have this, we can have it to be x raised to power x, then again x raised to power x. Because when you have a raised to power m, then a raised to power n. So this, we can also have it to be a raised to power m, then multiply by n. So by applying this expression here, then we are going to have this, then we are going to have our answer to be equals 2. Now guys, by introducing ln to both sides, let us introduce ln to both sides. By taking ln of this, we have it to be ln of x raised to power x, then raised to power x raised to power x, then this will be equals ln of 2. That is, by introducing natural log this to this side, and when you have ln of a raised to power b, this will be always equals when you have b ln a. So by applying this expression here, so now from here, we're going to have this to be coming here, then it will be x raised to power x, then ln x raised to power x equals ln 2. Then we have to recall that when you have ln x, this will always give us x. So now, by applying that expression here to this, so we can have this to be ln x raised to power x by applying this expression here. So we're going to have it to be e, then ln x raised to power x. Then we have everything to be equals ln 2. Now, from here we have to recall from W function, when you have W of x raised to power x, this will always give us x. And what are we trying to say here is that once you have the base and the power to be the same, then when you take W alpha function of it, that the inverse of this and this will give us this back. So now by applying it here, because we have our base to be this and our base to be this, they are the same. So therefore we can have this one as well to be W of ln x raised to power x, then e raised to power ln x raised to power x. Then we have it to be like this. and this will now be equals W of Ln2. And the theorem says once you have W of x raised to power s e raised to power x, this will give us x. That means we are going to have this back because they are the same, which implies that we are going to have Ln x raised to power x would be equals W of Ln2. And so therefore we can apply this expression here. That is, when you have Ln of a raised to power b, this can be written as b Ln a. So therefore we are going to have this here again to be x Ln x equals W of Ln2. And so therefore, guys, from here we can also introduce this logarithm expression here. That is, when you have this will now be Ln x, by introducing this one will be e Ln x equals W Ln2. So therefore, guys, again we have to introduce W alpha function again. That is, when you take W alpha function of this Ln x, then e raised to power Ln x, this one will now be W of W Ln2. And mind you that this from here will give us, since the base and the power are the same, so we are going to have Ln x to be equals W of W Ln2. Now from here, to get the to get the value of x, when we take exponential of both sides, this will cancel this. So therefore we have our x to be equals e then raised to W of W Ln2. Like this. We can name this to be question 1. Now we have to recall that when you have W of x raised to power x, this will give us x. And we should note that this equivalent to when you say you have W of x, then e raised to power W of x. So now, which means that from here we can have our x to be equals W of x e raised to power W of x. And by dividing both sides by this, W of x, this will take away this, which means that we have from here e raised to power W of x will be equals x divided by W of x. And when we take note of this to be question 2, now guys, when we now recall from here, we have W of e raised to power W of W of Ln2. Then that means from here our x will now be equals, when you have this, we assume the whole of this here to be equals x. And if that's to be the case, we're going to have our x from here to be equals we have this, then we can introduce this one, will now be W of ln 2 by substitute this one divided by, again, W, then into W of ln 2. And that is the final answer for the value of x. And when you substitute this one into W alpha function, you are going to get the value of x to be equals 1.379970396611. So if you like, you can have your x to be equals 1.38, approximately to 1.38. So if you are new here, once again, don't forget to share, like, comment, and subscribe to my YouTube channel for more mathematics tutorial videos. Bye bye.